All right, everyone, welcome to the penultimate installment of GISC 605 Fall 2023. It's been a pleasure so far with you all, and I'm looking forward to finishing strong. Before we dive deeper with Python, we're going to kind of look ahead, go through the quick study guide I prepared, answer any questions, perhaps debug some audio issues that Matthew's having. Please let me know if you can hear me. And then we'll kind of just work on the lab. So yeah, I'd say Matthew maybe rejoin. Uh, cool. Good to hear it's just Matthew. Sorry, Matthew. Let me share my screen and we'll jump into the study guide. And I guess before that, uh, I didn't get as much grading done this weekend as I was hoping. So you'll get more grades throughout the rest of this week into the weekend. So hopefully that'll give you an updated idea on where you stand. But overall, everyone's crushing it. So I wouldn't worry about it too much. You're all doing great. But I'll get on it. Besides that, as we're kind of winding down the semester, don't hesitate to reach out to me if you have questions about code, whatever, technology, even if it's after the semester. Feel free to DM me on Discord or send me an email. I'm available, so I just want to make sure you all remember that. Besides that, I think we can just get into the study guide. But once we go through this a little bit of logistic stuff, I will open the floor for questions. What other classes, if any, are you teaching and when? I'll mention it more in the lecture slides. So teaser, you'll find out soon. Cool. Sorry that I don't have a good answer yet, but I want to build some hype. Yeah. So let me share my screen. Using a vertical monitor, so Zoom is giving me grief. Don't worry, I won't share a vertical monitor because that would suck for you all. But here we have final lab study guide. So hopefully it's nothing that's surprising. This is all stuff that we've kind of done repeatedly throughout the semester. So if anything is surprising, please do let me know. But it's really just a combination of stuff that we've already covered, maybe slightly different questions, slightly different data, but very similar. So the content that you should know, like I will absolutely test you on it. Like this is me saying right now, I will test you on this. Please know this. How to create a GitHub repository and modify it. This is something we've done in the labs. So using the previous labs as a study guide or further study material is highly recommended. Same thing, using GitHub Codespaces. This is something we've done. Be prepared to do it again. That's all I'll say. But if you want practice, I'd say rerun through some of those labs or just experiment on your own and just tinker. Some other things that you'll be kind of tested on. I don't like using the word test, but it's more checking that you're engaging with the content. But writing bash commands and perhaps writing a small script with those bash commands. This is something we did in labs. So you could very much use those as study material to refresh your memory in case you've forgotten some stuff, which is totally okay. So there's nothing wrong with that. And then finally, we're going to round out the final exam with writing Python code in Jupyter Notebooks. So something like Binder, maybe not exactly Binder, but something like it. So familiarize yourself with that, which we did last week during our lab and we'll do again this week. So that's really it for the content. I'm not going to throw any crazy curveballs. I'm not trying to artificially make it hard for no reason. You can expect a pretty similar difficulty to previous labs. with that being said, the test is open notes. So don't feel like you have to memorize a bunch of code ahead of time. Uh, you can use your previous labs and the internet to answer questions. Um, I don't recommend just going to ChatGPT and being like, answer this for me, please. You could, but sometimes it's wrong. And I'll check your answers. Um, and so I'd say uh, use your human brain with the power of the internet to supplement it, but don't just copy paste an answer from a large language model. Uh, and then I will be available from 6 to 10 in Zoom, kind of like this, to answer any questions. The final is real time, so it'll happen next week, but it should not take you the full 4 hours to complete. Um, if you need some kind of accommodation because of some scheduling snafu or whatever, please do reach out. Um, the earlier the better, but I think uh, the previous lab should really give you an idea of what's expected, and I think you should have more than enough time to finish uh, all the sections. I'll and for context, it's not going to be like 6 lessons rapid fire. It might be uh, questions that kind of build on each other, and so the format might be slightly different in the sense that uh, it might be some more guided questions, but I'm going to very much try to set you up to do the proverbial windmill 360 slam dunk and succeed. I don't want anyone to fail. I want everyone to get A's. And so I'll do my best to make sure that it's not confusing, but it's still a test of your uh, learnings from this semester. And so, with that being said, are there any questions regarding the final? Feel free to do the chat or unmute, whichever you prefer. Okay, no questions. Or sorry if I'm talking over someone, I don't hear you, but seems like no one has any clarifying questions. If anything comes up throughout tonight, uh, don't hesitate to ask. And if you have uh, specific accommodations you need, just email me and I'll get back to you. What else? Yeah, that's it for study guide. And you can view this on your own time in our course website under the 7 final lab. On the day of the exam, I'll update it with the link, and then you'll all be able to get started. So with that being said, let's pivot to today's lecture. Should be a pretty quick one because coding is more fun. So diving deeper with Python. This is officially the last lecture of our class, for the slides at least. So feeling a little sentimental, but thank you all for having or being a great class and just being engaging and trying hard. So I appreciate that. But yeah, let's just jump into it and then we'll get into some code. But yeah, I appreciate that. I feel that, Daniel. Yeah, cool. So today's objective, and apologies, I removed the snake uh, GIF to ease your fears, but I forgot to replace it with something. So my bad for all this blank space. Apologies. Yeah, Fernando. So I want to familiarize you with more concepts and practical functions of Python, kind of applying it specifically to kind of a more data analytics use case, which I think a lot of you are interested in. Like, how do we easily and efficiently analyze data, like spreadsheets, and eventually spatial data types like GeoJSON, shapefiles, TIFF files, etc. So this is kind of the step 0 and 1. And then continue building your self-confidence as new developers. So I want you all to remember that you are developers now, whether you like it or not. I mean, you don't have to be, but you're in the club if you want to be, because you've started your journey. And so just continuing on that journey and reminding yourself that even through the error messages, through the frustrating, uh, head scratching, red font, terror inducing, just dread, it's going to be okay. You will learn and you'll overcome that error and you'll remember how to do it next time when you see it again, because things always come back to haunt us. But today, not to just ruminate on the haunting of error codes, let's really dive in to Python and specifically data analysis with Python. I'm not sure how versed you all are in the Python ecosystem, but or if you did any digging between last week and this week on libraries that might be interesting to you. But Pandas is one that I have a feeling many of you will use perhaps in your applied project for your degree, or maybe even at work. And so I think giving you some exposure to this tool will benefit you greatly. There's other similar tools in different programming languages, but I'd say in terms of industry usage, Python and Pandas will give you a bit more of an edge than alternatives like R and the tidyverse. But enough ranting. Let's address why there's so many pandas on the screen. Pandas is this open source Python data library. I think pandas was chosen because it's kind of a shortened version of panel data in a weird way. I was trying to look up today why, but pandas. It's not actually the logo of the library, but it should be because pandas are cute. But this Python package empowers you to do fast, flexible, and expressive data structures so that you can more easily work with relational or labeled data. And so that might feel like a lot of jargon, which it sort of is, but the last sentence in this quote really gets to the meat of it. And Pandas aims to be the fundamental high-level building block for doing practical real-world data analysis in Python. And it really is that. It's so ubiquitous across industry, academia. Pandas really, it's kind of like Microsoft Excel is to spreadsheets, as Pandas is to kind of like Python data processing, and even many machine learning projects too. And so if you're getting some awareness of Pandas, you're really opening this whole vast new world of possibilities on what you can do with data. And so I'm really excited to kind of start that journey with you all. And so let me actually go to this link real fast. So this is not the official Pandas website. We'll go there later, but I wanted to link Pippi, which is the official Python kind of package distribution website. And so you can see they have pandas available here, and you install it using something called pip. We don't have to worry about today because we're using Binder and it magically does that for us behind the scenes. But this website, pip, is kind of a repository of thousands and thousands of different packages that have special use cases. And so you can search for projects and easily install them. And this is kind of crazy cool. Like this is all open source code that's free that you can kind of just download and start using, start modifying. And so Pippi is this Python specific code packaging dissemination platform, whereas GitHub is kind of like everything. And it doesn't have the best interface for just kind of consuming specific things like this with a nice, I guess, overview and descriptions and links and stuff. Pippi is specially tuned for Python. There's other versions for different languages like NPM for JavaScript and blah, blah, blah. But this is a common thing you'll see in different programming languages, but I'd encourage you to check out Pippi and all the different packages. Actually, this doesn't really show you anything, but yeah, 500,000 projects, 5 million releases. So and then almost 800,000 users. And so there's a lot of people building things with Python here, and you can contribute to that, which is pretty cool. And then this also links out to the official website for Pandas, which I'd encourage you to check out. There's great documentation on getting started with Pandas. There's even free textbooks on how to do data analysis with Python that you can just view, which is pretty cool. And then you can see some of the sponsors of Pandas. If you're into gaming or computing, you might see some familiar names like NVIDIA, Intel. That's because they do machine learning stuff. And so Pandas is super cool for preparing data to do awesome machine learning things. It's not only what you can do with Pandas, but it's a pretty big use case. So I'd encourage you to check out Pandas website, their PIPI site, and then their GitHub repository. So we can see there's something like 40,000 stars, 1,000 plus people watching it, 17,000 forks. There were changes added yesterday, and this is a seriously big project. There's 3,000 contributors. This is like a monumental project. And so it's used by over 1 million projects. Like Pandas is massive. And so getting some exposure to Pandas will really give you a leg up when you're talking to, I'd say, any kind of tech organization that has any interest in data, because someone on their team is probably using Pandas. So what is Pandas? It's cute. I mean, I want to go see this in real life. I know they're statues, but it's still cute. Okay. And then what is Pandas, or why does Pandas matter to GIS practitioners? And so Pandas is great and all for using or for manipulating and modifying tabular data that doesn't really have a spatial component, but there's this geospatial variant to Pandas called GeoPandas, and we're going to use that extensively for data analysis next semester in, you guessed it, the next class that I'm teaching with you all, GISC 606, Applied Remote Sensing. So this was kind of what I teased before, but I'll be back in the spring. So you'll miss me for a bit, but I'll be back. And we're going to use some of the learnings that we built this semester in that class next semester. So as a teaser, it's focusing on applied remote sensing, but we're still going to be using GitHub, Bash, Python, all that good stuff. So get ready. And then I think with that, we can jump into the lab activity, but let's actually check out these interesting links that I compiled. So GeoPandas is, like I said, the geospatially aware counterpart to Pandas, kind of like PostGIS is to PostgreSQL. And so you can see how there's parallels there with these software packages. And so these are some examples of what you can do with GeoPandas. So something that you might have heard of in your other GIS classes is a spatial join. I'm not going to read through this whole mini tutorial, but GeoPandas lets you do spatial joins, which is pretty cool. Not the prettiest example of, or quickly discernible, like, oh, a spatial join happened. They didn't do like a nice plot, but there's a spatial join happening using this S-join method. There's other examples here that I'd encourage you to check out. Some of them are a little psychedelic, but it's just showing you the kinds of things that are possible when you're programming with your data, and you can kind of let your imagination run wild. So this is almost making me think of like geospatial art, that somehow you're being creative and depicting things at the same time. But yeah, we're going to dive a little deeper now with a specific use case of GeoPandas that we might encounter next semester, and that's sampling data. And so you might have some vector data, and you might want to get information about the image at these specific blue dots. And so we can use GeoPandas in conjunction with a library called raster.io to accomplish that with Python. And so we're going to get some practice with this next semester, but I'd encourage you to take a peek at this learning resource and learn some of the stuff that we'll be doing next semester. And then to round out the why does this matter examples, I wanted to include one that kind of had all the buzzwords. And so we're doing geospatial generative AI on AWS with GeoPandas. And so this is kind of like taking your Python GIS chops and then actually deploying them on the cloud. And so this is kind of like a white paper blog that goes over how Amazon created the solution of deploying their kind of, it's like their ChatGPT trained for geospatial things. And they're just using Python to do this. And you can see they're using GeoPandas, pandas, and then writing a function to do some analysis. Look at all those if statements. Goodness gracious. And it's really just not the craziest Python. And so I'd encourage you to check out this blog and see if you can understand what's going on, especially maybe after tonight, after we get some practice with pandas. But I'd encourage you to check this out, and you can see they're creating a visualization with some 3D components using Python and integrating with Amazon, cloud computing resources. And this is some of the cool stuff you can do once you're opening or using open source kind of GIS technologies that allow you to build almost like application experiences with a bit of Python code, which is pretty cool. Not all of you are going to really want to do this or need to, but just seeing, we're just trying to share that these are the useful things that you can build once you go a little deeper with Python, and then maybe learn a little bit about AWS. You can actually build an application that people can interact with, which to me is pretty cool. Or you can kind of be on the team building that and contribute non-technically, which is also super cool. But with that, let's jump into this week's lab activity. And before we do that, I'm going to open the floor for questions. Are there any questions before we jump into the lab? Yeah, and if you'd like to reach out about the final, any questions about the class, email works, but so does Discord. DMing on Discord always works, and it'll probably be a little faster, but I will get back to you on email as well. Cool. So it doesn't seem like there's any other questions. So with that, let's jump into this week's lab. So I'm seeing a question from Uniba. Is AWS similar to what Microsoft offers? Yeah. So it's called the big three. There's AWS, which is Amazon Web Services. There's Microsoft Azure, and then there's Google Cloud Platform. Those are the three main cloud providers that really compete with each other and serve a lot of big companies. And kind of picking which one is I don't know that anyone is better. I'd say they're all kind of similar. It's really more, what is the team that you're working on using already? In my experience, that's oftentimes more the what happens. I'd say maybe don't use Google. I'd say that Amazon and Microsoft are a little more popular, but either one of those is probably your best bet. Yeah, more AWS and Azure in cases, to be honest. Yeah, it's those are most common. Google, it just depends, but yeah, it's definitely less common. They're all very expensive, especially when you're running uh, like a big application. And so it's tough. Yeah, it's not it's not cheap to run in the cloud when you're at the scale of a company like Azure or Planet. So they have loft or they have big uh, cloud bills, for being real. But there's ways to pay less, and there's also alternatives where you're not using Amazon or Google or Microsoft. It's kind of a smaller provider. Uh, you might have to do a little more configuration, but you pay a lot less. You might pay like a fifth of the price. And so there's a huge surcharge for going with Amazon. It's kind of like a name brand. Um, you can get cheaper, kind of, or more value for money from a generic option, oftentimes. Cool, great question. Um, and let's get into the lab. So, like last week, we're going to create a GitHub repository and kind of add IPython files to it throughout the night. And so I'm going to toggle screens real fast or rearrange things just to make it easier for myself to multi-screen. So I'm going to stop sharing for a second and then I will reshare. But I encourage you to navigate to your GitHub account and then we can go from there. And if I haven't gotten back to you on Canvas or Discord, apologies, and I will get back to you ASAP. All right, where's the share screen? Cool. Get the chat back. Great. Okay, so this is my GitHub profile. Um, I'm gonna now go to my repos, and then I'm gonna, oh, what's this? You'll see this next week. So let's create a new repository and continue with the lab. So I'm gonna call this Python part 2. I'm not going to use a template. I'm going to make it public. I will add a README. That's it. You can skip everything else. Okay. Next, let's get started with some of these lesson notebooks. So I'm just going to jump right into it. I said last week the same thing. I don't know if we're going to make it through all of them, but there were fewer last week. So I really don't know if we're going to make it through all of them tonight, but we'll see what we can get through. But let's just jump in. Some of them are not as long. So this is the L4/functions.html one, just titled functions. We're going to use binder. Uh, so I'm going to click that. I encourage you to do the same. And we'll just wait a moment for binder to initialize our notebook and create the workspace for us to do some code. Thinking. Yeah, Binder's struggling. Maybe everyone's on Binder. I'm getting impatient. Let me try again. There we go. Okay, it's sort of. Is Binder being slow for everyone else, or is it just me?
It's good on my end.
Okay, cool. Good to know. Uh, oh well, extremely slow for you. Okay,
It took me
maybe.
a while too, but it's good now.
Okay, cool. All right, I'm just pulling up an alternative option for myself in case Binder does not want to collaborate, cooperate more appropriately. Oh, there we go. Okay. As soon as the other one loaded, it was like, oh, wait, stay. Um, Hopefully it's working for everyone else, but let's get right into it. So, what is a function? So you can see there's a little weird formatting issues here, but it just means to say a function is a block of organized reusable code that can make your programs more effective, easier to read, and simpler to manage. And you can think of functions as little self-contained programs that perform a specific task that you can repeatedly use in your code. One of the basic principles in good programming is do not repeat yourself dry. And so, in other words, you should avoid having duplicate lines of code in your scripts. So you shouldn't just copy paste the same line 10 times and change one number in it. You should write a function to do that and then just run that function however many times you need it. So functions are a good way to avoid situations like that, and they can save you a lot of time and effort. So you don't have to tell your computer to do the same thing over and over again. So we've used functions throughout, I guess, last week, using things like print. Those are functions we just didn't have to write, and they're called built-in functions in Python. And so today we're going to probably use some more built-in functions and then write some of our own. So let's dive into the anatomy of a function. Um, We'll consider the task from last week's lesson where we converted temperatures from Celsius to Fahrenheit. So it's a common operation doing something like that, like a data conversion. When you're dealing with temperature data sets, you could also convert to Kelvin. Um, and so it'd be useful to have that as a function so that you don't need to constantly write that math formula whenever you need to convert. You can just invoke some kind of Celsius to Far function. So let's create that. And we'll use this little image as a cheat sheet, but we're going to define Celsius to Far, and it's going to take an input parameter called temp. And our function is kind of a short one. So we're not even going to have like multiple lines. We're just going to return the conversion. And so if you input a temp into this function, we're going to return the converted value into Fahrenheit. So it assumes that you're giving Celsius data. So we have this function, but it doesn't actually do anything. It just makes the logic saved to that phrase. And so no conversion has really happened. We've just kind of told our computer to remember whenever we call the Celsius to Far thing, uh, spit out that converted number. So let's try our new function. And so it's the same thing as like calling print, except we're going to call our function. So let's define a variable that we're going to input into that function. So we'll call it freezing point. That's the degrees Fahrenheit we get when we're using our function. Temperature 0. And so let's do freezing point equals Celsius to var, and then we're going to input 0 degrees Celsius. And so then let's print out our freezing point. 32. Nice. Similarly, we could input a different value and we'd get a different number output. 20. We then get 68 degrees. Voila. We magically have functions running, which is pretty cool. You could imagine your function is much more complex. Maybe it's converting between TIFF and IMG files, or it's maybe performing some kind of spatial smoothing operation over your data set. It could be whatever you need. So we can do the same thing with the boiling point of water in degrees, and let's try that. I kind of did it with 20, but let's do it with 100. So print Celsius to var 100. Nice. 212. Looks about right. And so this also gets to another interesting concept. You can kind of put functions inside other functions. And so the Celsius to Fair 100 does a calculation, but it doesn't actually output anything. And so you can then have the print function output that value, which is pretty cool. So let's make another function because we're all going to be function pros. And like I alluded to before, you might not always want to convert between Fahrenheit and Celsius. Sometimes you might want to convert to Kelvin, which is the absolute temperature unit. And so let's create a function that does just that. So let's do define kelvins to Celsius. We'll do a temp. And then we want to return the value in Celsius. And so Celsius temperature is just the temperature in Kelvin minus 273.15. So we'll take temp minus 273.15. And we've defined our function. Now let's use that function and make sure that it's working. So we'll say absolute 0 equals 0. Because it's a concept that you might hear in physics classes. It's where it's like the slowest theoretical possible, or the lowest theoretical possible temperature in the universe. It's when physics starts working strangely, things change. But it's this concept that physics nerds like. And so let's take absolute 0, and then let's convert it to Kelvin, or to Celsius. So kelvins to Celsius, absolute 0. Negative 273.15. It's pretty cold. Cool. So let's check our understanding with a little more physics. Sorry if this is making you die on the inside. Promise you there will be no physics on the final. It's really just trying to give examples of where you might need formulas that should be functions. So Isaac Newton developed a scale for measuring temperatures, which we're not going to look into now, but it's linked here on the Newton scale. And that was a precursor to modern day Celsius. And so in his system, water would freeze at 0 newtons and boil at 33 degrees Newton. And so it's difficult to directly convert between the two scales if we assume, however, if we assume that the increments of temperature change are equal, we can kind of come up with our own temperature conversion. It might not be like the same conversion over the whole range, but we can do a simple estimate here. And so if you want, you can create a function. Take this as extra credit, I'd say, but we're going to skip it. But that might be a fun test of your function understanding. So I previously alluded to functions within a function. So kind of piping in the Celsius to Fair into the print statement, but you could also kind of pump your custom functions into your other custom functions in the same way. And so let's do that here. So we're going to create a function that is just invoking those functions. So it's almost like abstracting it even one level above. So define kelvins to Fair. It takes the temperature in kelvins as the input parameter. And actually, let's call it temp kelvins. Now we're going to invoke the kelvins to Celsius function. And so we'll do Celsius temp equals kelvins to Celsius. New spelling. Temp kelvins. And then we'll do return Celsius to Fair, and then Celsius temp. Let's see if this works. So if 0 is negative 273, or 0 Kelvin is negative 273 Celsius, it's also going to be something kind of small in Fahrenheit. I don't exactly know, but let's find out. Kelvins, Fair. Yes, that's nice and chilly. And let's see if that actually holds up. So I'm going to do, so the value is negative 273.15. So let's check it with Celsius to Fair. And you can see that they match. So our kelvins to Fair function is correctly converting to Fahrenheit using our Celsius to Fair and our kelvins to Celsius functions. Sorry if that was kind of confusing, but yeah, we're just kind of writing a function that calls on other functions in a specific order to then get a more interesting result. And so you can see how that might be useful in data pipelines where you're moving data from one place to another, maybe transforming it, maybe calculating interesting aggregations on it like means or totals and stuff, and then saving that data somewhere else like a spreadsheet or a database, you name it. So let's do functions and variable names now. And we're getting towards the end of this section or of this notebook. So a common point of confusion for new programmers is understanding how variable names and functions relate to those defined elsewhere in your code. And so it's important to remember that when defining a function, the variable names given in the function definition only exist when the function is being called. So if you write some variable, it's not going to like magically persist after you call that function. So if you need it to exist after, you need to actually return it. You need to like save it somehow. And so let's kind of explore that a little bit. So we're going to define a modified version of our kelvins to Celsius function, where the parameter value is still called temp kelvins, but now we're going to store the converted temperature as temp Celsius first and return that value. So I'm just going to copy paste our kelvins to Celsius function and then do a little bit of modification. So kelvins to Celsius. So we still have a parameter value called temp kelvins, but now we want to store the converted temperature as temp Celsius and then return that value. So let's do temp Celsius equals temp kelvins minus 273.15. And then we want to return temp Celsius. So we've defined our function to accept temp kelvins as the only input parameter, and then it's going to calculate temp Celsius and return that value. So the variables that we defined in the function only exist there. If we do this, or if we just invoke temp kelvins, we get a name error because it doesn't actually exist. It's just kind of this name that we set for the input to this function. It's not actually a variable or a value that exists anywhere in our code yet. It's really just this kind of label to the input. And then similarly, I don't believe we have a temp Celsius unless I assigned it elsewhere. We don't. So you can see the same issue, same name error. It's not defined. And that's because we're defining it in the function, but it's kind of this like semi-existence. They're intermediate kind of values that only exist as long as you're calling that function and saving it, the information somewhere, but then they disappear instantly. So it's kind of this ephemeral intermediate variable. Hopefully that makes sense. So now let's skip through some of this because it's kind of just belaboring this point. Why does Python work this way? There's the benefit of having separate kind of namespaces for functions. That's a little jargony, but it's basically saying it's helpful to define kind of spheres or zones where functions can exist and where others can't. And just for the kind of usability of the code, that's a helpful way to write applications. So I'd say you don't have to dive too deeply into namespaces because that's kind of more of a computer science construct. But as long as you get some understanding of how to write functions from this notebook, I'll be satisfied. And as long as you really complete everything up until this section here, you're good on full credit for this notebook. The functions and variable name section is a little bit, it's fine, but there's some repetitiveness. So with that being said, I think we're done with functions. So let's save this notebook, download it, and then we'll upload it to our GitHub repo. Lots of downloads. What's it called? Functions. Cool. Now we have our Python notebook here with the work we did. And yeah, let's continue with the next lesson. Are there any questions before we continue? Okay. Don't hesitate to unmute or ask in the chat throughout. the lab. Yeah, now we're going to Notebooks L4 script files and opening it with Binder. Might take a second again. This Binder's slow at times, but might be quick. It's thinking. A little faster this time. So in this lesson, we're going to introduce you, or we'll introduce ourselves, to how to put functions in a script file for convenient use in notebooks or other script files. And so it's kind of taking it up another step and making our code reusable and shareable. So up until this point, we've been keeping our Python code and Markdown comments in a single Jupyter notebook, which is great, but there are some cases where you'll have like a long Python code block or a set of function used in many notebooks. And so you don't want to have to copy paste that Python code into each of these notebooks. That'd be a huge pain. An alternative to typing in all the commands is to run them, like run the list or like a list of commands. But a Python script file is probably the best way that you can just trigger Python logic to run. And so it is the list of commands that you'd like to have the Python interpreter execute for you. And so we're going to write some script files, which you'll see as a .py. So the .ipynb is specifically a Python Jupyter notebook, whereas the .py is a Python script file. So let's create a new Python file. We're going to click the file, new Python file. And so now you'll see that there's a second pane here, so I can toggle between the script files .ipynb and the untitled.py. And you can see that that's depicted here. And likewise, in our file explorer here, we can see the untitled.py appears. So let's copy paste this function into the Python script, the untitled.py. So I copy that into my clipboard, and now I'm pasting it here. Now I'm returning to the script files just to get the instructions, but we do want to save it. So let's save it using just Control or Command S or Control S, depending on your operating system. And you can see we want to rename it. So let me cancel that because I want to get the name that we should rename it to. Let's rename it to tempconverter.py. Converter.py. And so you can see now the name has been updated on the pane here, as well as this file tree explorer. Cool. And then we can verify that we have our function Celsius to Fair in here. So now let's learn about saving and loading functions. So functions like the one we just created can also be saved in the script file and called from a Jupyter notebook. And that's often how you'll be using kind of libraries because they're just Python script files behind the scenes. And so let's dive a little deeper and save a few more functions to that script file and then call those functions. So I'm going to copy paste these additional functions, kind of similar to what we were doing previously, converting kelvins to Celsius, kelvins to Fahrenheit, and Celsius to Fahrenheit. So I just added a new line, pasted in the content, and then saving our changes. You'll note that as soon as you make an edit, there's like a circle that appears here. And until you save those changes, the circle won't disappear. But I don't really want this gibberish here, so I'm going to delete it. And then click save again. So we've created a script file that we can call from a notebook or another script. Now let's get some practice with that. So let's make sure we're in the right directory. I believe we are, but we're gonna make sure we are. And so you can kind of magically run certain bash commands from Python or from a Jupyter notebook at least. And so one way to do that is using the %sign and then doing ls, and then it'll output directly to your terminal what is there. Another way to do this is writing the exclamation point ls. They're kind of just two different shorthands of triggering bash commands from Python. And so you can see we have a functions.ipynb, modules, script files, and then also our temp converter.py, which is pretty cool. So we are not CSC notebook users, so we're not going to see that. We are binder users, so we might see something a little more like this, which is cool. Or actually, no, we don't. And so what we see is correct. And we're going to confirm that by seeing the temp converter.py. If you don't see that, kind of backtrack and make sure that you're following the instructions correctly, or perhaps change into a different folder. And so now let's import our function from the script. So we're going to do import, or no, we're going to do from temp converter import Celsius to Fair. Now let's use that. So if we do Celsius to Fair of, how about we do 0 degrees? Yeah, 32, so that works. Cool, so our function is behaving as expected. So now we can use that function inside like a print statement. I like this. So we might do an F string, which we learned about last week. What else? We might put in some human readable text, the freezing point of water in Fair, and height is nice. And so you can see how we're able to use our custom function that we're importing from a script inside our notebook, which is pretty cool. But say you have a really big temp converter file and you want to import everything. So you don't want to have to do that for, say you have like 100 of these and you don't want to have to import each one individually. You can import everything using some trickier import statements. So let's do import temp converter as TC. And this might remind you of when we were using other libraries like math and how we'd have to call math.sign. Similarly now, if we want to invoke anything from the temp converter library, we have to prepend it with the TC period. And then we can use Celsius to Fahrenheit. We can use Kelvin to Celsius or Kelvins to Fahrenheit, which is pretty cool. And so here's an optional advanced topic. Let's check it out. Let's see how tedious or annoying it is. It might be fun. So far our functions have only had one parameter, but it's also possible to define a function with multiple parameters. Let's make a simple temp calculator function that accepts temperatures in kelvins and returns values in either degrees Celsius or degrees Fahrenheit. The new function will have two parameters, temp K, and that's the parameter for passing the temperature in kelvins, and then it'll have a convert to parameter, which determines whether to output in Celsius or Fahrenheit. And so you have to input a C or an F to indicate that you'd want that. So we'd start, I guess they're straight up just doing it for us, which is chill, but we can just walk through this code logic. So we'd start out by writing just our function definition, def temp calculator. And instead of having a single input, we have two inputs, like they described previously, temp K, and then convert to. So we'll use the convert to input parameter to kind of add some conditions to our function so that depending on whether the user inputs a C or a K or an F, we output a different conversion value. And so you can see that if convert to equals C, which is for Celsius, we're going to set the converted temperature by converting from kelvins to Celsius. If the convert to value is set to F, we're going to set converted temp using the kelvins to Fahrenheit conversion formula. And then finally, we're going to return the converted temp. And you can see how very quickly we created a much more complicated but useful function in our program. And then if we wanted to, we could add a doc string, which is a very good practice for programmers, so that future you or others who might use this program are set up for success and know what the parameters do, how you're supposed to use this function, what it returns. And so it's a really good practice to add comments to your code. So now we should have a temperature calculator that we can use. So this doesn't look like it's code. It's more like Markdown. So I don't know if this will work. We might have to retype it all. Yeah, okay. Let me copy paste this into, well, actually, let me do the one with the doc string because that one's prettier. So let's copy paste that. Let's try that out. And then let's test out our temp calculator function using this temperature Kelvin variable. So temp calculator, let's actually do help temp calculator. And then you can see the real nice benefit of adding a doc string is that when you're in help, it just kind of knows to output what you put there, which is super nice. So let's do temp calculator, temp Kelvin, and then we want to convert to, say convert to Celsius to start. Ooh, we got an error. And this is where sometimes you might get issues of things not being loaded because you're reloading modules from within a Jupyter notebook, and it can be a pain. And so the easiest option is to restart the IPython kernel by going to kernel, restart kernel. This will delete all the variables stored in memory. So you may have to rerun some cells, which is fine. Let's try that and see what happens. So kernel, nope. Kernel, restart kernel. And then let's try this. Okay, so that works. That works. Oh, and so if we put this in, that technically works, but we're going to still get an error because it doesn't know where to look for those functions. And so because this Kelvins to Celsius thing doesn't exist. And so that's because we have to prepend it with that TC. Same thing here, TC. And this should work, hopefully. Yeah. And so it was just an issue of Python didn't know where to find that Kelvins to Celsius or Kelvins to Fahrenheit function. If we now try it with converting to Fahrenheit, we should see that it works. Very cool. And then what happens if we put in something that's not a C or an F? Like what if we do a lowercase f? You see we get an error. And so it's case sensitive and it only responds to C or F. You could add another branch that maybe handles that case. Else. Return. Not a valid option or convert to. And so let's see what happens if we run that again. Not a valid option for convert to. But then these two remain unchanged because they are valid options. And now if we try something else, like what if we put in just like gibberish? Yeah. So it just handles for everything that isn't an uppercase C or an uppercase F. So this was a quick dive into script files. For this one, for this lab, let's download the script files and the temp converter file. And so I'm going to download script files. And then I'm also going to download this one. Let's see if there's a way to do that. Yeah. Download. And then I'm going to go back to GitHub, upload some files. I'm going to add, I already forgot what they're called. The goldfish brain. It's a long day. Temp converter. And then what is the other one called? Jeez. I already forgot. Script file. Sorry, guys. Started at 7:30 today. Wednesdays are tough. Cool. And then if you want, you can check the Python file and see what it looks like on GitHub. Has the nice syntax highlighting, but it's still just Python. Very cool. I'm going to close out of this one and return to assume. Being annoying. Okay. Are there any questions from that script files example? So let's keep going. I promise we'll get to the pandas soon, but having an understanding of this will give you an appreciation for pandas, what it is, and how to use it. So bear with me. It's being slow. Well, that is disappointing. Let's try to refresh this. Come on. Okay, let's try again. Thinking. All right. Binders being annoying. Man.
It's definitely not just you, Alex.
Okay, cool. So I'm going to share an alternative way to do this. So I just shared a link to something called Google Collaboratory, which is Google's way to run Python in Google Drive. So let's kind of see if we can make this work. Uh, I'm going to download, oh my goodness, Zoom, so annoying. I'm going to download this lesson here using this little download icon and click IPYNB. And so it's not going to be helpful. And so we actually have to save this now. I'm going to save this as modules. And now we're going to go to that Google Colab link that I shared. And we're going to upload this file that we just downloaded. So I already forgot what it's called. Modules. Okay. File, upload notebook. I'm going to browse, and we're going to select modules. And now you can see it's not as pretty, but it should get the job done. I might toggle this one every so often just to make sure we're getting everything, but I think we should be okay. Hopefully this is working for you all. I don't think this will have lag like Binder does. It's just some manual steps. But let me know if you run into any issues, whether you continue with Binder or you decide to use Google Colaboratory. If Binder's loaded, then stay with that. This is more just an alternative workflow. Binder was not working for me, so it should be basically the same. The Python will be the same. So let's get into it. So a Python module refers to a piece of Python code that is designed to execute a specific task. Technically, modules are just Python script files that contain functions and other statements. Python packages are just a way of organizing modules into larger entities. So modules and packages are similar to what are more generally called libraries in programming languages. And so that's just code that is related to a specific task, like mathematical operations. And there's a ton of Python modules and packages, and many of them greatly extend what you can do with normal Python. And there's a ton of free ones. That is why learning Python is it's a great move. There's just a lot of free open source tools that you can use as long as you learn some Python. And so something that might trip you up a bit, but the word module, package, and library are used pretty interchangeably, even if they're not quite the same thing, but people tend to use them interchangeably. So let's start with loading a module. You can import them using an import statement like this. Math is a default module that's just installed with Python. You can see it's taking a second to load, but now we're good to go. And to kind of tie back into what we were talking about earlier, Google Colaboratory is running on Google Cloud Platform. And so that's one cloud. This is not a workspace you can use forever. It's more of like a playground to learn and experiment with. This code, or your code won't get deleted, but your variables won't just be staying in memory forever. I think that Google wipes this every hour or 4. And so don't just expect that what you're working on will be in memory. I mean, none of your code will get deleted. It's just you might have to re-trigger, like re-import math because your computer went to sleep. But like before, we can run the square root of something and expect 9 as the result, or -9, but we're not dealing with that. And so we loaded the math module using the import statement, and that tells Python to read in the functions that are in the math module and make them available for use. You could very similarly import some GIS module, and then you are having these functions available to use and do GIS things. So these concepts apply even when you're not just doing square roots. So there are some built-in functions like the print, but we don't have to actually import it. It's just there. However, sometimes you might want to rename functions for the sake of, I guess, succinctness. Especially with pandas, you'll oftentimes see its import aliased into something else. In the case of math, we could maybe import math as m, and then instead of having to type math.square root, we just do m.square root. Similarly, a library we're going to be using in the next lesson is pandas, and it's most often imported like this. Import pandas as PD. If you don't want to import a whole module, you can just import a single function as such, and then you could just run it like this. This can be useful, but it does have drawbacks because sometimes that function you imported might have a conflict with another function that you have imported, and so that you lose kind of where the context of where it's coming from, and so it's messy. So only do it if you really have to. Sometimes you don't want to import a whole module. You can import just a submodule. Not all modules have submodules, but some of them do. And so pyplot is a submodule of matplotlib, and this is a library you'll get very familiar with when you're doing data visualization. It's very often used in conjunction with pandas to display data on charts. You can also use it with GeoPandas. So you'll likely get some exposure to pyplot next semester. And you can see we just calculated a simple line graph. Or didn't calculate, we created one. So moving on, you can use module functions. The easiest way to use a module is to import it and then use its functions by specifying module name.function name. But there's times where you may not know all the names of the functions in a given module. For that, you could actually list out all the functions in the module. And here we're doing that on the math module, and you can see all these different trigonometric functions, exponential things, just math stuff. And also you can run help on a module or a specific function to get information about that function, which we also did in the last lesson when we wrote the docstring. What should I not do? Here are a few things to avoid. This is something that you'll see it, even though people say to avoid it, you'll still see it done. I'd say this is something that you'll come across, the from X import everything. The asterisk is kind of just like the wild card. Just anything that's inside X, please import it. And so that's super powerful, but oftentimes extremely unnecessary. And you're loading in a bunch of code that is kind of bloating your computer. And so it's just better practice not to do that. Likewise, you might be accidentally importing things that have conflicting names that will just give you a headache when you're trying to debug. So don't do that. And then a second thing to avoid is renaming things with weird names. So like import pandas as PD is fine because it's kind of a general convention, but doing something like importing matplotlib as M and then also doing import math as M will very quickly confuse you or anyone trying to read your code. Similarly, doing something like import matplotlib as math is probably really bad because people will be expecting like sign functions, but it's actually a plotting library. And so that's just some general wisdom with respect to modules. And then if you're using your own computer, which none of us are today, this is kind of just a plug for some tool to use. I would encourage you to give it a read, but we're not using it, so it's not really in the scope of this lesson. But that was it for modules. Hopefully Binder works for the next one. But to save this and download it, you should just be able to, I think it just auto saves, and then you can save it to GitHub directly, but sometimes you have to authenticate and it's annoying. So let's save a copy of this because we did make some changes, I believe. Or let me just download it, the IPYNB modules. We'll call it modules collab. And now let's upload this file. Then we'll check to see if the changes were persisted or if I messed up. Yeah, it looks Looks fine. Okay, cool. I'm gonna close Google Colab, and then we're gonna try with Binder again. So let me open the floor up for questions if anyone has any questions for L4 modules, but now we're jumping into pandas. So hopefully it's a little more interesting. But some of these are actually pretty quick. So it might seem like a daunting 7 sub-lesson lab, but this one might take 5 minutes or less. So what is pandas? It's a modern, powerful, feature-rich library that's designed for doing data analysis in Python. Blah, 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 marketing hype, but it's really cool. Not to be super pessimistic. But there are documentation and good examples that will help you get up and running. And so I know I've said it a bunch of times, but Pandas is like an industry standard library for a lot of analytics and just data processing tasks. So I encourage you to lean into learning it and leveraging it on your resume, portfolio, CVs, what have you. It's a useful skill to market. So what are some of the benefits of Pandas? It's easy to use data structures. And so data is typically stored in something called a data frame, which looks like a table with rows and columns, something like an Excel spreadsheet. And so columns contain data of different data types. And so this is very similar to how data is stored in Excel or R, but it also uses the concept of a data frame that kind of adds some built-in conveniences that let you kind of manipulate and investigate your data very easily. And so Pandas also combines functionalities with many other modules. And so it plays really nicely with NumPy under the hood, which is used for doing kind of array mathematics. You can think about remote sensing image data as very big arrays, just like numbers, like stacks of numbers. And so NumPy is used to do a lot of like number math on big stacks of numbers. So Pandas is kind of this interface that lets you do a lot of that stuff, but more easily. It's like a nice UI. Kind of how some products are just like smooth and nice out of the box compared to others that are a little more finicky. You have to configure them, tinker with them to actually use it to the best of your ability. And so NumPy is one module that Pandas plays really well with. Another one that we mentioned previously is Matplotlib. And then a third one is SciPy. I don't know if we'll have any SciPy next semester, but we'll definitely have Pandas, likely NumPy, and definitely Matplotlib. And so a cool thing about Pandas is you can read and write to and from many data formats. So CSV, JSON, HTML, Microsoft Excel, SQL, to name a few. And so that's pretty cool. You can read in a Microsoft Excel file and then save it to a PostgreSQL database, or vice versa. You could read a MySQL database and then output that as a CSV to share with a colleague. I don't know why you'd necessarily want to do that, but you could. And so for this one, there's not actually a binder lesson to download, so don't bother with downloading it and uploading it to GitHub, but I did want to walk through this one with you all. You can think about that as 14 points just automatically you got. So you're welcome. Or 14% of the score. So now this one has a little more coding. Exploring data using pandas. So let's try to launch this in Binder. Hopefully it loads. And if it doesn't work, we can always try with Colab. Oh, it's loading. Okay. Exploring data using pandas. So we're going to learn how to read and explore data in Python using pandas, and I believe we'll have like a CSV that's already installed here for us, or a TXT file. Okay. So a pandas data frame is used for storing and manipulating table-like data. So like an Excel spreadsheet. You can think of it as a programmable spreadsheet, literally. Whereas a pandas series is just one of those columns. It's used for storing and manipulating a sequence of values. It's kind of like a list, but it's a little smarter. And so a row or a column in pandas is a series. And so these pandas structures leverage some of the things we've talked about previously, like indices. Remember, like when we have a list and we can do position 0, position 1, storing different types of data together, like in a list. Pandas can do a lot of cool things like that, but in the context of a spreadsheet. So let's have some fun. Actually, let's check this out. And so you can see that this far left column is the index column. So this first observation is index 0. You can see there's a series called year moda, another one called temp, one called min, one called max. And these are data values, they're observations. Each of these columns is a series in the pandas data frame. And then similarly, you can zoom into one of these specific series and kind of view it here. And then they also have those associated index values. And so it's very much just kind of a way to assign a position to data in the table. I'm going to skip over some of this because it's kind of just reiterating the same thing over and over again, but pandas is just like a streamlined package that helps you interact with things like NumPy and do cool stuff with numbers. But you can also do cool stuff with text as well. So our input data is a text file containing weather observations from Kumpula, Helsinki, Finland, and they were retrieved from NOAA. And so this file is called Kumpula June 2016 with metadata.txt. We can take a look at what it looks like if it decides to load. Oh, I clicked the wrong thing. Oops. So here is the text file. You can see there's some metadata at the top about when it was collected, where it was collected, some guy's name, and then the actual observations. So we're going to have to deal with this kind of header before we can read in this data. So let's figure out how we're going to do that. So let me move the zoom thing because it keeps giving me grief. Wait. Yeah, I clicked the wrong one. Okay. Okay. So file is available in Binder, so you should have it. If you're using Colab, you're going to have to download it, which is fine, but just know that. It has observed daily mean, minimum, and maximum temperatures from June 2016, recorded at this specific weather observation station in Finland. And there's 30 observations, so there's one for each day. So let's read this file using pandas. To start, we need to import pandas, and we'll do that using import pandas as PD. Next, let's read in the input data file using the pandas read CSV method or function, excuse me. So we'll do data equals PD dot read CSV, and then there should be some, yeah, autocomplete goodness. Just do tab to do autocomplete, and then separator equals a comma, because you could have like a tab separated, a semicolon separator. So pandas lets you just put that, which is nice. You don't even have to. By default, it just assumes that the separator is a comma, but it's helpful to specify sometimes. So let's read this data into memory, and we didn't get an output. So let's actually see what happens when we call data. So it's kind of ugly. Like it's almost there. You can see that we have our observations, some indices, the column names, but then all this metadata that we don't actually want in the table is getting read into columns or rows. And so we have to account for that. And this is going to be a lot of your work with pandas, is kind of learning the ins and outs of kind of working with data, because it's oftentimes not perfectly clean. There's going to
Hey,
be
Alex,
weird. Hey, what's up?
can you scroll up just for like a quick second? I just want to make sure I have that a little bit further. There you go. Okay.
Yeah, it's the one it's in the markdown here. It's kind of just copied. Yeah, cool. So let's try to skip over these rows. So in this file, like we saw here, there's 8 lines, 1, 2, 3, 4, 5, 6, 7, 8, where there's like extra junk that we don't care about. I'm including this extra blank line. And so we're gonna tell pandas, hey, skip some rows. So let's do that like this. I'm gonna copy paste this because I'm lazy. And then let's add an extra input parameter called skip rows. And we're going to set it equal to 8. And now let's reprint out what our data looks like. And you can see that this looks way more like a spreadsheet that you could actually filter, sort, do math on. You know what I mean? Like do useful work on. It's not just kind of a mess of weird metadata in addition to the data. However, you can also see that we still have these NaN values, which is not a number, none, null. And so this is where in your endeavors with data in Python, you'll learn about kind of filling data, making it so that when there's null values, your code can still deal with it. And so oftentimes you don't want to look at the whole data set. When it's longer than 30 lines, it'll oftentimes be kind of there'll be like a dot 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 ellipse in the center, and it'll just show the first few and the last few lines. Let's say you want to specifically view the first 4 rows or first 5. You can invoke the head function or head method on your data frame. You could also specify you just want the first 3, and then you'll get the first 3. Similarly, you could do data.tail to look at the other end. Say you want 6, the last 6 records. You could do that like this. And so pandas data frames have things labeled axes. So those are the rows and the columns. You can see here how these are kind of emboldened. And so the rows are labeled with an index value going from 0 to 29. And the columns are labeled with your MODA, temp, max, or min. And so later on, we're going to learn how to use these labels to select and update subsets of data. Because oftentimes you don't want a whole global data set. You just want to filter down for a specific subset, maybe only the observations where the minimum was above a certain threshold. You can do that with Python really easily, just like you could in SQL or SQL for sure, but also Microsoft Excel, doing kind of formulas in your sheets. The same kind of ways of calculating values and creating new columns apply in pandas. So let's confirm the type of our data variable. The type of data, it is a data frame. Cool, cool, cool. So let's try to read in the contents of that file again, but we'll store it in a new variable called temp data. And we just want to read specific columns, namely year MODA and temp. So it should have 30 rows and 2 columns. And so we're going to use the useCalls parameter to specify which columns we want. And you can navigate to the docs to learn more about useCalls. This is the read CSV method in Pandas. I'm just going to control find for useCalls. Hopefully something comes up. Oh, it's Zoom is doing me dirty. Okay. UseCalls. So it's a list or a hash of hashable or callable. And so it's a subset of columns to select. So we're going to pass useCalls and then specific names that we're interested in. So here you can see an example where they're saying foobar. For ours, we want to do year MODA and temp. So it's going to be temp data equals pd.read CSV, poompula, blah, 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 blah. Skip calls equals 8. Okay, we want the sep equals comma, and then we want to do use calls equals year MODA and then temp. And then if we do temp data, ooh, we got an error. Skip calls. Is it not called skip calls? What is the skip rows? Okay, so I used the wrong. That happens. It's okay. Ooh, and another error. Because there's no underscore. It's useCalls. Okay. So there's just a typo on my part. And now you can see we got exactly what we were expecting. 30 rows, 2 columns, telling Pandas to just read only the data we want, which is pretty cool. Let's continue on our data frame exploration. Let's check the size of our data frame. You can do that using the len function. 30, okay, cool. You could also do that and get another metric using the shape attribute. And this will tell you kind of the length and width of your data set to give you an idea of how it's shaped. So it's got 30 rows and 4 columns. You can also check the column names in your data frame using the columns attribute, data.columns. You can see how this is kind of a weird index thingy, but if you actually just want a list, this is still sort of not exactly what you want. So you'll learn these as you kind of use Pandas more and more, but you can save the column names or represent them as a list. And here we have it. The type of this is actually just a list. Hence the to list method. Oh, and I got a typo because I didn't have a closing as a list. And then you can also print out information about row identifiers using the index attribute. And you can see it's a range index starting at 0, stopping at 30 with a step size of 1. You can make custom indices. Maybe you need a step size of 2, or you want to stop at 43. It's kind of arbitrary, but it just gives you an idea of how your data is indexed. So what about the data types for each column in our data frame? You can print information about that using the dtypes attribute. So we'll do dtypes. And so you can see that year moda is an integer with 64-bit precision. Temperature is a float with 64-bit precision. And similarly, max and min are floats. So is there a way to print out the number of columns in our data frame? I'll give you, actually, let's look at the docs together, actually. That'll be more interesting. So say you want to just look at let's figure out where the data frame. The pandas data frame, and we want to, what do we want to do? Print out the number of columns in our data frame. So we could do data dot columns. We do len data dot columns. Yeah. So we have 4 columns. Okay, that was pretty easy. So say we want to select specific columns based on column values. So like a conditional selection. So we can do that. Let's select 2 columns from our data frame. So the data, and then we want to have year moda and temp. So you can see now we have these 2 columns. We can check the type of this selection. So type, it's still just a data frame. And so we're just subsetting the data frame and looking at specific data, but the underlying kind of data structure hasn't changed in pandas. You can still do all the same data frame things to a subset as to the full data set. You can also access a single column of the data based on the column name. This is when it gets kind of messy. And it's kind of like, oh my goodness, there's so many square brackets, but you could then do this and just get temp after you, so you're subsetting a subset, basically. It's kind of annoying, but say you're saving this to a variable called like subset data equals data. Then you could do subset data temp. And you're just getting like temp. You're really just assigning values to variable names. You can also invoke or just output the column by passing the name of the column. As such, also works for your moda, but know that this is only works when there's no spaces or weird characters in your column names. If there was a space, I'm pretty sure, yeah, it would just break. So you'd have to use another method of subsetting. So something that's really commonly done with pandas is kind of descriptive statistics. Say you got a bunch of observations from a weather station. You want to maybe get the average or the total days where the temperature was above a certain threshold. You can do that using the descriptive statistics functions in Python. So let's get the temp. So let's try that mean, see what happens. And so if we run data.mean, we'll see that we get the average for all of them, and then I believe we can just pass in a column name here and just get 1. Oh, we don't. Interesting. Okay. So to get the mean of a specific column, you could do like this. And then to get all the means, this. Excuse me. And then you can also easily get overview statistics about a data frame using the describe method. And so this will give you the count of observations, the mean, standard deviation, the minimum, and then percentile values. So this is pretty cool and just a built-in kind of method in Pandas. So let's check our understanding and see if we want to do this very basic plotting. So it doesn't make much sense to print out descriptive statistics for year MODA because it's just year month data. And so let's see if we can print out the descriptive statistics again, but only for the temp, max, and min columns. So let's look up the data frame describe attribute and see if we can't figure out a way to ignore one column. So a blacklist of data types to omit from the result. Interesting. So we know that there's a type. What is the type of year MODA? What data.d types? So one way we could do this, I suppose, is strings can also be used in the style select types. Okay, let's try this. I know like the easy way to do this, but I'm trying to do a little more interesting. So data, and then we want to dot describe, and then we want to pass in exclude x equals, it has to be a list. Okay. And then int 64. See if this works. Nice. So here, when I ran describe, it ran it across all 4 columns, but when I did the exclude int 64 data type, the describe attribute only ran on temp, max, and min, which is pretty cool. So next, let's jump into some very basic plots. So we actually don't even have to do anything. We're just running this code that's already there. So just run that code and you'll see a plot. And it's not the prettiest, but it gives you an idea of the types of things you can easily start doing once you have your data in a data frame format. Sometimes you might not immediately have your data in a file that can be easily read in by pandas. You might just have lists. And so you can actually convert lists into series and data frames using pandas. And so here we have this series that we're creating of just numbers, 4, 5, 6, 7. And then we are, and you can note that pandas magically makes everything a float, even though some are integers, but because one is a float, they all become floats. You could also set a custom index, but we're not going to really do that, but it's possible. And then you can see how we're passing in lists into some variable names, and then we're just creating a pandas data frame using lists and just passing them in to the data frame method. You can see we have a data frame. Similarly, you could start with an empty data frame and add data to it that way with the existing lists. So it's really up to you, but this is kind of a quick overview of how you can explore data with pandas, and we'll get much more exposure to this next semester. So now let's save this file. download this file and upload it to GitHub. Well, I already forgot what it's called. Man. Explore data using Python. I'm going to miss teaching you all, but I'm not going to miss long Wednesdays. Long Wednesdays are rough. I think we'll be meeting on Saturdays in the spring, so it'll be a different energy. I might have a little more zest. Who knows? Okay. So what's next? Processing data with Python. I think we just have it here. So I'm going to open it here so I don't have to class in person in Joshua Tree. Maybe, yeah, we'll do I mean, if y'all can make it out here, we'll arrange something in the spring to have an on-site or something. That'll be fun. Cool. Okay, let's do this. I'll have to talk to Wexler and see if we can get some department funding to like reserve some building or something. Cool. Literally, no, that'd be sick. Yeah, camping desert class. Yeah. It would totally be optional, but I think that would be a fun opportunity for people to come out. I live right by the national park, so we could reserve a group campsite and parking wouldn't be an issue. We can't fly drones there, unfortunately, but I'm sure we could figure out ways to link it with applied remote sensing. Maybe we'll get some satellite data of that area. I'll have to think about that. Yeah. Okay, let's jump into the last real lesson of the night. The errors one is pretty quick. It'll probably take us 5 minutes. So this is kind of the final meat. This is really the last bit of new content for the semester. So once we get through this, you should be kind of off to the races for prepping for the final. So let's get into it. In the previous part of this lesson, exploring data using pandas, we learned some of the basics of pandas data structures, i.e. series and data frames. And we got some practice doing exploratory kind of descriptive statistics, subsetting the data. And now let's dive deeper. So because we're in a new notebook, we have to re-import pandas. We're also going to have to reread that data into our work environment. And so we're going to use the same file as before, but this time let's actually save that file name into a variable that we can more easily call on. Sorry, I got distracted because there's like Christmas lights flickering in the neighborhood. All right. Oh yeah, quick aside, I saw my first coyote today in the backyard, which is pretty cool. I've seen them in LA when I used to live there, kind of occasionally in the neighborhood, but this is the first one I've seen so close. It was probably 30 feet away from me and just kind of walking through the yard, chilling. So that was kind of a cool nature moment. All right, so let's define a file path. We'll just call it data path. And we'll set that equal to the Kumpala thing. And tab complete is a lifesaver. And then let's save this into a data frame. And a convention you'll often see in examples, even some like live notebooks that are used in companies is DF. And it's just short for data frame. And so we're going to do DF is short for pd.read CSV. And then we want to read in data path. Then we want to do a sep. Actually, we can skip that. It's because it'll just know. Actually, it might not because it's a TXT file. When it's a comma separated value file, like a .csv, it'll just automatically detect that it is a CSV. So I think the only reason we're doing that is because we're using a TXT file. Then we want to do use calls or skip forgetting. Was it skip rows or skip calls? If anyone remembers, feel free to yell it out. If not, that's cool too. I guess I could just check here. Being lazy. You'll learn that the deeper you get into programming, the lazier you might become, for better or worse. Okay, skip rows 8. That's what it is. And then let's check it, see that it looks good. Looks great. So note that our input file is located in the same folder as the notebook we're running it from. And so furthermore, the same folder is the working directory of our Python session. For these two reasons, we're able to pass only the file name to read CSV. So that's like just this part. If we were anywhere else, we'd actually have to put in like the folder. And so the absolute file path to this data in this environment is this. You could also use that in the input when reading the file, but it's kind of just annoying. And so I'm going to skip that because we don't really need to do that. But you might see that occasionally in the real world. So let's define a new column because this is a pretty common thing that you'll come across in pandas. So let's say df, and I'm going to do df equals 0.0, and then let's do df head again. Nothing happened. Cool. Let's now try it with the correct syntax. It's okay. It happens. I really got to get a light for my keyboard when it gets dark like this. Okay. And so now you see if we have the diff using the correct formatting, we're able to easily add a new column to our data frame that's pre-initialized with all the values that we want, namely 0.0. And then if we would like, we can check the data type of our column. I'm just going to check all the data types, and we'll see that it is a float 64. And automatically recognize that it's a float when we pass the 0.0. So now let's update the column diff by calculating the difference between max and min. And this will give us an idea of how much the temperatures have varied during the set of days. So let's do df diff equals df max minus df min. And then we'll just do df head again. So you can see for most of the records, it looks great. However, in the cases where there's a nan, the diff is also nan. And so let's continue. Just something to know. So we can also create new columns on the fly when doing the calculations. You don't have to have columns existing ahead of time. And it's possible to do math, addition, multiplication, whatever, when you're creating these new columns. It's up to you and your imagination and what you actually need. And so if we wanted to, we can convert the Fahrenheit temperatures in the temp column to Celsius using the formula we've already seen in this course many times. And so let's do that here. We're not going to import the function from our module. We could if we really wanted to get tricky. So we're just going to have, we're going to write that formula here. So it's not the best practice, but for the case of learning, we're not really focusing on importing modules right now. We're learning about what you can do with series and data frames. So let me do data or df Celsius. Let me call it temp Celsius. That equals 9 divided by 5 times df temp plus 32. Could be wrong. I always forget it, but we can always change that. Fix it real quick. Yeah, it's wrong. Okay. What is the Celsius to Fahrenheit formula? I want to convert 5 divide. Oh, okay. So I was doing temp. Celsius is 5 divided by 9 times df temp minus 32. Yeah, this looks way better. This looks way more in the realm of possibility. So like, yes, 60 to 70 degrees Fahrenheit is around 18 to 20 Celsius. That's gut check about correct. Cool. And so you can see in real time, we created a new series using just some math, and it's calculating a useful value for us. So let's try to do the same thing with Kelvin. So we'll do df temp Kelvin equals, and then it's df temp Celsius plus 273.15. And then df.head. So you can see now we have the temperature in Fahrenheit, Celsius, and Kelvin. So before we did some subsetting across columns, now let's select rows. And so let's select the first 5 rows of our data frame using row index values. And so we can do that using 0, colon 5, and this will return the first 5 rows. And it's index 0 through 4. The bottom left side of the index is inclusive, and the top right-hand side is exclusive. So it is not including the 5th, or is the 5 index. It is 0 through 5th position. Okay, and so let's select several rows and columns. So you can do that using the pandas dataframe.lock method, which selects data based on axis labels, so row labels and column labels. So to start, we can do df.lock, and then let's check the docs to see what we're up against. So df lock Viper, Viper Sidewinder. Interesting. So let's try this out. So it's actually square brackets. So you can see similarly to the DF 0 through 5, we can get just the temp values by doing temp, getting 0 through 5. However, here we're getting 6 rows of data because we're doing the selection based on axis labels instead of the integer index. And so this is some kind of difference, subtle difference in behavior to note. When you do DF 0 through 5, here you're getting 5 results, whereas when you do DF temp lock 0 through 5, you're actually getting 6 results. Okay, it's also possible to select multiple columns when using lock. And so let's try that. So let's do df.lock. And then here we got, let's do 0 through 5. And then the list of columns, let's say we want min and max. Cool. And so you can see how we're pretty sophisticatedly, if that's even a word, subsetting this data set by integer positions and specific columns, which is pretty cool. So let's check our understanding and try to find the mean temperatures in Celsius for the last 7 days in June. So we're going to do the selection using row index values. So that's going to be this method here, index slicing. So let's relook at our data again. So we have df. So we want the last 7 days in June. So that's going to be these final 7 observations. So to get that, we should be able to do -7 through 0. Never mind. 0 through -7. There we go. So that's wrong as well. There's a specific, okay, yeah, I'm messing up the order. So if we want, so if we do -7 colon, there we go. So this gives us the last 7 observations. 1, 2, 3, 4, 5, 6, 7. And then let's get the mean. And we just want the temperature. So let's see like this, and then just want temp. And so there, the mean temperature of the last 7 days of June is 64.85 degrees. Right, I'm guessing. So that would be very hot Celsius, especially for Finland. Okay, so you can also select a single individual row from a specific position using the lock indexing method. So let's select all the data values using index 4. So df.lock 4. Cool. So now let's print out one attribute from that selected row. So we do df.lock 4 and then temp. Nice. And so you can see how we're just reading this value here. It's in scientific notation, but it's still the same 51.4. You could also select a single value based on a row and a column. So you can do that using the dataframe.lock method. or the data frame dot at method. So let's look at the docs real fast. See how they're using it. df at for b. So let's do df dot at 0 temp. And so you can see that it's showing a value of 65.5. If we then return just the first row, you'll see that the temperature is 65.5. So we're just kind of subsetting and filtering the data in different ways. So here we have some optional challenges. Let's see if it's interesting. You can also select by integer position. It's not that interesting. It's honestly kind of confusing, but feel free to run these, what's it called? Cells, making sure to update with the correct data frame name. But you can see that you can kind of index across columns and rows using integers as well. So you don't have to specify column names like temp. You can just do 0 through 2, which is year moda through temp. If we updated this to 0 through 3, we'd then have 3 columns. And so it's just another way to filter your data. Some might be more useful for you than others. It's really just kind of depends on your use case, how your data is structured, and so on. And here we're just showing the different ways you can use iLock with your data set. So let me take a quick sip of my water. So a really useful feature in Pandas is the ability to easily filter and select rows based on a conditional statement. So let's select rows when the Celsius temperature has been higher than 15 degrees, and then store those in a variable called warm temps. So Pandas will check if the condition is true or false for each row and return those rows where the condition is true. So check the condition. Let's do this. So we have our data frame. So data frame where df is, or df dot temp is greater. Select the rows when the Celsius temperature has been higher than 15. Okay, so it's temp Celsius is greater than 15. So here you can see if we look at the temp Celsius column, all of these records have a temp Celsius greater than 15. And you can see we're missing a bunch of our records. This is not all 30. So I kind of skipped ahead, and this is actually this step right here. We're here just checking a condition. And so we can actually see the trues and the falses for all the rows and saying, oh, it's true in this row, false in these, true, etc. And so you can kind of get an idea of the pattern of the temperatures. There's a little cold spell here, but the rest of it was kind of nice. Here we're actually subsetting and filtering that data using that condition, but we can also get a little crazier if you want. So let's select temperatures above 15 that were recorded on the second half of June. So year moda is greater than this integer. So let's copy this. And then we'll do an and operator using the ampersand. And then we want to do df.year moda is greater than or equal to 2016 0.0615. So we got an error, which is chill. Let's try df or df and df your moda. There we go. So you need to put in parentheses. I just forgot. It happens sometimes. And so you can see here, we have even fewer results where the temperature Celsius is warm and it is after June 15th, which is pretty cool. So we have a subset of results where the temperature is above 15 and it is this latter half of June. So you can notice how here there's these numbers that are out of order, especially because we've subset it. And so let us save this data into a new data frame, and then we can drop that index if we want. So let's say reset index test, just so that I remember what this is. So reset index test dot reset index. Actually, we don't even have to save it into a variable. We can just pass the reset index after that, which I totally forgot. Let's just do that and see what happens. And you can see now that it takes the original index and creates a new column called index with the original data, and then creates this new index column. If we want to get rid of that original column, you can just do drop equals true and see how that does not propagate that old information. And now the values go from 0 to 12. So let's see if we want to check our understanding. Can we find the mean temperatures for the last 7 days of June again? Yeah, no, I'm good. Okay. So in this lesson, we've been storing subsets of data frames as a new variable. And in some cases, we're still referring to the original data. And so any modifications that we make on the new variable might affect that original data, which can be scary. And so if you want to make sure that you're not modifying your original data, you should make a deep copy before doing things. And so you make a deep copy using the copy method. And so if you wanted to make a copy of df, you could do df.copy. So let's say df copy equals df.copy. And so this is a deep copy of df that you can edit, and it will not affect this. If you didn't include this copy right here, oops, and you just set that equality and then started doing things to df copy, you're potentially screwing up df as well. And so that's the case where making a copy of things is nice sometimes if you want to maintain the original data. Previously, we were kind of encountering a bit of missing data. And so this is where you might want to drop NaN values or columns that have NaN values. And so you can do that using the drop na function. And so let's do that on df, drop na. And so this removes columns for which there is an Na value. And so you can see we're missing 2, some other ones 7. This is a common procedure where if you're just missing values, you'll drop the whole row, which is fine. But now we might want to reset that index because these indexes are now, or indices are not totally sequential. Another option that you could do is filling in the no data using the fill now method. And so you can do that like this. And so here it's actually giving us an error because we didn't specify how we want to fill those NaN values. And so something you might see in your remote sensing classes is an NaN value of a negative 9999. And so we're going to do that now, and we'll see how the data set has been updated, where we're not going to get the errors for the no data, but we'll know that this is also just a kind of a placeholder. It's not actually the information that we need. And so it's often dangerous to fill the no data with specific values because you might accidentally mess up your analysis. But if there's ways like using negative 9999, you could perhaps have some check to make sure that you're not using that for any kind of real computation. But always check to make sure you don't have some weird results that are created because the NANs were filled with some very large negative number. So we're kind of getting close to the end here, but you can also convert between data types. You can truncate floats. You can round them. I encourage you to experiment with that. I'm not going to go through all those right now just because it's kind of not the most exciting, but we'll see what we can. So df temp head. So let's try df round. So here now we have what happens if we do round 1, 2. Okay, and so we're just changing the number of decimal places that we're considering. And then you can also cast it to an integer. Because if you're just having a bunch of trailing zeros, you don't actually need it to be a float. I'm getting an error because cannot convert non-finite values NA or infinity to integer. Interesting. Where are we getting that? df. Okay, so I didn't actually fill the df. Okay, so let's do df dot fill na negative 9999. And let's round it to 0 and then as type integer. So you can see here now we have all these values, including the large negative. Similarly, you could round, but I'm not going to spend more time on that. Oftentimes, it's useful to get the unique values that you have in a specific column. You can do that using the unique method. And so that would be like df temp. See, and you're getting the unique temperature values. The list. I want to see the number of unique temps and printing out. There were 28 days with unique average temperatures. Interesting. Another thing you might want to do is sorting data. You can do that using the sort values method or sort values function. So that'd be df.sort values by equals temp. And so you can now see it's ascending temperatures, and you can see that the day indices are totally out of order because it's following temperature. Similarly, we could order it by max. And you can also sort descending, so just the false ascending. And then finally, as we start to wrap up, you can save your data to a file. So let's call our output file name Compola temp results, June 2016 CSV. So we'll call output file equals Compola temp results, June 2016.csv. And now let's save our data frame to CSV. And you can see suddenly we have a new file that was created in our file directory, and it is a spreadsheet, or it's a CSV file. Very cool. And then the first value in the data file has the index value of the rows, or this whole first column is kind of just the index, which is kind of annoying. There's a way to skip that, but we're not going to cover that today. But you can find that in the pandas doc. Actually, index is false, is the parameter that you run. So let's actually do that real quick. There's also quite a lot of decimals in the columns. I don't really want to deal with the decimal nonsense, so I'm not going to do that. But I will remove that index. Index equals false. And so now when you reopen that data set, you see that it's not with that extra column. So if we really wanted to, we could make things prettier. So what, float format? Yes, let's try that. Float format equals, see if that does anything. And then when we open this again, didn't look like it did anything. Oh, it did. Cool. And now all our data is nicely truncated, a little easier to read. And we have a cleaner output file. So now let's save this and download the processing data with pandas and the CSV file we generated. It's here. And then let's upload this to GitHub. So we got processing the pandas and then something. And pull a CSV. Commit our changes. And now if you want, you can view that CSV file and it's nicely displayed in GitHub, which is pretty cool. Let's kind of slowly start wrapping up our evening. We have one last sub-lesson for the night, dealing with errors. I don't believe there's actually any code we have to run. So it's really more of just a reading through this one, but you're going to encounter error messages in your Python code. And so I just encourage you to feel whatever dread you'll feel in the moment, but don't let it wash over you. It will get better. We can overcome these error messages. And oftentimes Googling the exact error code will solve your problem. More often than not, you're not the first person to have encountered this problem. And so copy pasting your error message into Google will oftentimes just the first or second result will be the answer. So I encourage you to don't be shy about Googling error messages because you'll get answers. Even like pasting the error message into ChatGPT, it'll help. Yeah. And so this lab, it's really just kind of running through the types of error messages you might encounter, where we have a syntax error, we have type errors. Another error we've encountered previously is a name error. And so I would just encourage index errors, another one. These are just things you're going to encounter in your code. And so just figuring out how to quickly resolve them will be to your benefit. Here's another error, an indentation error. And so I just encourage you to, you don't have to memorize all these error types so much as understand that you're going to encounter them and figure out how to quickly Google your way out of whatever dilemma you're in. So with that, this is kind of the end of today's lab. We basically went through it all. Two of the sections were kind of don't even have a submission. By that I mean the pandas overview and the errors. So you should be good to go. And then speaking to Viviana's question, I try to, it depends on how fast Zoom is working and YouTube, but it should be up by tomorrow morning. It's really just, it takes some time to process on my computer tonight, and I might fall asleep just because I'm tired. But as soon as I wake up in the morning, I'll start uploading it to YouTube. I don't have like a script that on download from Zoom instantly upload to YouTube. That would be a nice Python use case. I've been too lazy. So at the latest, like tomorrow morning, late morning sometime. Yeah, I'm going to stop sharing, but I will be around. But this is kind of it for lectures this semester. Yeah, no, do it for extra credit. I'll throw points at you if you make that script to make my life easier. Sounds good. But yeah, it's been a pleasure this semester. Don't hesitate to reach out after the semester, and we'll see each other again. I think March is when my class starts, so you'll have a little bit of a break from me. So hopefully you don't forget too much. But yeah, we'll be using GitHub and Python and stuff in the spring.
Have a good night, Alex.
Hey, you too. Thanks.
Good night. Thank you.
Yeah, good night. Thank you. See ya.
Hey, Alex, is your class going to be similar to this one where it was half the semester?
Yeah.
Okay. Right on. Well, I appreciate it. Thank you for everything.
Yeah, of course. Thanks for attending and screen sharing. Yeah,
For
appreciate
sure.
it. See ya. How's it going, Ari? Have any questions or kind of just hanging out?